In this example, we're going to solve a radical equation that contains one square root. What we'd like to do first is isolate our square root on the left-hand side of the equal sign. So we can do that by subtracting 1 from both sides. Now that we have the square root isolated on the left-hand side of the equal sign, we can square both sides of our equation. Remember that you have to square the entire right-hand side. So over on the right, we're going to get x minus 1 all to the power of 2. Now we can work on simplifying each side. We know that the square operation is going to undo the square root operation. So on the left-hand side, we're going to be left with 3x plus 1. On the right-hand side, we're going to get x minus 1 times x minus 1. And if we expand this out, we should get x squared minus 2x plus 1. So notice now that we have a quadratic equation that we have to solve. So let's try to get this into standard form and see if we can factor it. So after collecting like terms, I get the following. 0 is equal to x squared minus 5x. I personally like having all of my variables over on the left-hand side, so I'm just going to switch the order here. And then I'm going to factor out the common factor of x. So we have two numbers that when multiplied together give us 0, x and x minus 5. So this means that either x is equal to 0, or x minus 5 is equal to 0, in which case x is equal to 5. So here are our two possible solutions to our original equation. Remember that the act of squaring both sides of our equation might create extra solutions that we don't want to consider. So we are going to have to double check these solutions. First, if we substitute in x equals 0, we're going to get square root of 1, which is 1, plus 1, which is 2, but over on the right-hand side we get 0. So x equals 0 is not a possible solution of our equation. Next, let's check x is equal to 5. If we substitute 5 into the radical, we're going to get square root of 16, which is 4, plus 1. So we have 5 on the left-hand side and 5 on the right-hand side. So 5 is the only possible solution here to the original equation.